right. Thank you for being here, everyone. Nice job, Nick. I don't know how you could even swim that long. I can't even run that far. And think about, like, why am I doing this? I don't. So again, thank you for joining us again. My name is Phan. I'm part of the technical product marketing team at HashiCorp. And today, we're going to talk about securing remote access into your complex environments using Boundary, and then we'll cover some of the latest announcements with Boundary as well. All right, so here's a look at the agenda. So we'll start off with what is Boundary for some of the folks who are probably newer to Boundary, have never used it before. We'll then take a peek under the covers and talk about some of the underlying components and architecture that makes up Boundary. And then we'll talk about some of the, the environments that it goes into. Then lastly, we will touch on some of the new releases, including Boundary Enterprise and session recording for SSH. All right, so what is Boundary exactly? Well, you can describe it in different ways, but I'd like to say that it's a platform that standardizes ways users can access their infrastructure. So very similar to how Terraform standardizes the way you can provision infrastructure in any type of environment. Boundary provides that standardized ways to access infrastructure regardless of whether it's on AWS or GCP or Azure or your on-prem environment, right? So from a user's point of view, what they would do is just log on to the platform itself, authenticate themselves using one of the existing identity providers like Okta or Ping. Boundary supports OIDC, and with its latest release, the .13 release, it also now supports LDAP as a beta capability as well. So once a user authenticates themselves onto Boundary, what next? Well, they're given a list of resources that they can connect to. Those resources, we call those targets, right? VMs, Kubernetes clusters, databases, right? Typical things that developers or users would want to connect to in your infrastructure. And then once they select to connect, what Boundary would do from a security point of view is provide security in layers. So it'll provide just-in-time access into the network itself. It'll also work with Vault and integrate with Vault to provide just-in-time credentials with permissions that are specific to that one user based on roles and based on things that the admin would curate for them, right? And then those permissions are always short-lived. Integrating with Vault is short-lived, and it can be revoked on demand as well. So if we take a look at the traditional methods of accessing your infrastructure, likely there are traditional ways like VPN access or using some type of a bastion host or jump host to get onto infrastructure. That obviously works. That gets them into the network. But the challenge is it gets them to the front door of that network, and they can just kind of meander and go anywhere they want in that network, right? And so, how do you limit or provide access directly to their end destination, right? You can do it by a few ways, by perhaps using a firewall that is, limiting access based on IP addresses. But as we all know, IP addresses are ephemeral. They're very dynamic. They come and go all the time, especially in any cloud environment. And resources themselves are also always dynamic. They come and go all the time. So having to manage a firewall and limit access based on IP addresses is very challenging. And how do you do that at a granular level for every different user as well, right? And then the other challenge is credential management. So lots of developers, lots of users are likely accessing multiple different types of resources, different VMs, different hosts, and those all have different credentials as well. So if the users are managing those credentials themselves, likely it's probably not the most, all the best practices are probably not followed. They're probably not rotating all the time. They're probably short, long-lived. And so there's some challenges and some concerns there with exposure potentially, right? So let's compare that now with how Boundary provides that access through a dynamic access workflow. So from a user's point of view, again, they would log on to their existing identity provider, right? Once they're on, they're given a role, and that role gives them access or authorization to access certain targets, certain resources, right? And once they decide to connect to a certain resource that only they are able to connect to, what happens is the Boundary provides them with access to the target themselves, and it injects those credentials directly in for that user, right? So that private connection is provided, the password credentials are injected, and the user never even sees it. So they get a passwordless experience from their end. So it's streamlined, and they don't have to manage those credentials themselves. All best practices are centrally managed through Vault. The user never sees it. Credential exposure is not an issue, right? Okay, so again, for some of the folks who are newer to Boundary, I'd like to take some time to talk about how Boundary works and all the underlying components that make up Boundary. So this is the main objective, right? We have users, and we want those users to be able to connect into the network, into the infrastructure, and access whatever they want to access, right? So those are, like I said earlier, they're called resources. So where does Boundary fit? Well, the first component that makes a Boundary is the Boundary controller. So this is, think of it as the brains of the whole operation, right? Boundaries where you go in and you would configure which users can connect to which hosts, right? That's where the control plane, main control plane and main management plane resides there. And this boundary control communicates with all the other components that are in that boundary environment, right? So, for example, the boundary client. Boundary client is something that a user would use, and they install right on their desktop or their laptop. Comes in different forms, desktop UI or a client or a CLI client, and that communicates with Boundary. And the user uses that to authenticate with the Boundary controller. And so once they authenticate, they can also use that to then connect into the infrastructure itself. So they're only interfacing with that client, right? Then, how do they actually get in? So they communicate with the boundary controller. The boundary controller tells them, okay, if you want to connect to these certain targets, here's where you go. It directs them to connect into the network, into the infrastructure using a boundary worker. So the boundary worker is really the data plane. It's the component that proxies all user sessions into the environment, right? So these are the three main components there. There are other components as well as an integration point as an option, right? So the first one being Vault. Boundary has a built-in credential store where you can go in and add credential stores within Boundary, and it can be managed within just the controller. However, many organizations use Vault today. Vault has lots of advanced capabilities to generate credentials just in time, rotate them, things like that. So we want to be able to leverage that and offload it onto something that's built for that, like Vault. So we integrate with Vault. And then, as I mentioned earlier, identity providers as well. So many organizations use various types of identity providers. So we support OIDC and LDAP. So that's all communicating with Boundary as well. So you can see how the Boundary controller really is that central control plane with all the different components interacting with that central control plane, right? All right, so now let's walk through what a user experiences, right? All these things happen under the covers and seems like magic, but from the user's point of view, it should be very simple. They shouldn't know about any of the stuff that happens in the background. They should just interact with their client. So the first thing they do is they use the boundary. I had the desktop UI as an example, but they can use the CLI as well. So with the desktop UI, they log in, right? They select the auth method. I'm using Azure AD in this example. All right. Boundary redirects them to that appropriate identity provider. They log in with Azure in this case. And then what Boundary does is says, okay, I know who you are. So you are provided a list of targets. You're only allowed to access these targets, right? So they present them with the targets. The user selects the target, right? And in the background, again, what happens is Boundary then communicates with Vault and says, hey, can you grab me, can I get the credentials, or can you generate just-in-time credentials for this one user, for this one machine? Credentials are sent from Vault to Boundary, all the way down to the worker, and now it's on the data plane. And the very last part is the client itself connects into the target using SSH. In this case, I'm using the terminal. Boundary provides a loopback address with a specific port number, so it can direct them correctly to that target, right? And the user just uses SSH with that port number and that IP address. They get right in, right? Again, no credentials are given out to the user. So that's a pretty simple topology. But as we all know, many organizations don't have just one single network like that. There's lots of different types of topologies and network configurations. So there are organizations that maybe perhaps don't allow any type of inbound access at all, right? So it's completely prohibited. They only allow outbound. Other organizations maybe have, maybe they do allow inbound access, but it has to hop through some type of public network that then is routed and routable to some other internal network that where the actual target resources reside, right? So it has to hop through multiple different networks in order to get there. So that presents challenges for end users to get into these different type of environments and different type of topologies and not have to understand the whole topology of everything, right? So one of the solution to this that we actually came out with in the last release, in the .12 release, was called multi-hop sessions. So the idea here is that instead of one worker in that one network that I showed you earlier, you can have multiple workers across these multiple different networks. And then these different workers would then connect to each other and form a chain, an end-to-end chain where the users would connect, finally be able to get proxied through all the way to the end network, right? And again, the user doesn't have to know about any of this stuff. And so we break the workers out into an egress worker and an ingress worker. The egress worker is a place where the resources reside in that same subnet, perhaps, or maybe it's routable to the resources, right? So that's the egress worker. And the ingress worker is where the client connects. It's placed in a network where the client can connect to that ingress worker. And together they connect to each other between the workers themselves. So let's go through an example here of a network where you have a public network and a private network. It looks like there's no squares around the network, but it's not a big deal. In any case, imagine well, actually it is. It's just not showing up on the screen. Okay. All right. So you have a public network and a private network in this case, right? So the egress worker in the private network makes an outbound connection to the ingress worker, right? So now there is a persistent connection between the private worker and the public, private worker and the egress worker and the ingress worker, sorry. So there's a persistent connection, and then the user would just use the client to connect into that ingress worker, and then they'll be hopped across those different workers to get to the end destination, right? So hence the term multi-hop sessions. So what about networks? What about organizations that don't have any type of outbound access at all, right? The network's completely private and only allows outbound. So in that case, we can still leverage our HashiCorp network where boundary resides. So if you've ever deployed HTTP boundary, when you deploy it, it automatically creates these HTTP workers for you in HashiCorp's network, right? And those workers are specifically for you to use. And so this HTTP worker can act as this ingress worker, right? So the same concept applies. The egress worker would make that outbound connection, form a persistent connection, then the user connects in to the HTTP worker, which is accessible, hops across that persistent connection, and gets through to the end destination, right? So these are just different ways to configure and connect into your different types of networks. It's not limited to two. You can have many more workers to connect this chain to form the end-to-end connection, right? Okay, so now let's talk about some of the new releases that were announced. Specifically, Boundary Enterprise and SSH session recording. So Boundary Enterprise was developed to help with organizations that can't use managed services like HCP, right? And then SSH session recording is basically exactly what it sounds like. It allows administrators to record sessions and obviously play them back as well to improve security. So we'll get into some of the details of that here. So when we first developed Boundary, one of the primary things we wanted to have or wanted to ensure is that Boundary is very easy, very simple to deploy, very simple to manage, very simple to maintain over time. So naturally, HTTP was the perfect fit, right? HTTP is our cloud platform. Many of our existing tools and products already use HTTP to provide a managed service, so it was a perfect fit, and we achieved that with HTTP Boundary. However, there are many organizations out there that simply can't use a managed service, right? Either they are, under some type of, compliance regulation that's prohibited for them using a managed service, or they're just hesitant to adopt it. And it takes them a lot more time to get comfortable with that, right? It includes multinational organizations, healthcare, government agencies, and and financial agencies. So for those reasons, we came out with Boundary Enterprise. So really, if you look at the main components of Boundary again, right? Boundary composes of the Boundary controller, the client, and the worker. In HTTP Boundary, the controller resides in the HashiCorp network. In Boundary Enterprise, it simply is deployed into the customer or the organization's own infrastructure. And along with that, all the underlying components as well. Key management system for the encryption keys, audit logs, and the Postgres database, right? So Boundary Enterprise is supported on any platform, which is agnostic to the underlying infrastructure. It could be any public cloud, any private cloud. It doesn't really matter. It's really whatever can install, the Go binaries, VMs, containers, right? Things like that. As in terms of features, is complete parity with HTTP and HTTP Boundary and Boundary Enterprise. The features are identical. So that's the nice part, that you don't really have to look at different matrices to understand what's supported and what's not. The only real decision point you need to make is, am I under a certain regulations that just doesn't allow me to use managed services? If so, Boundary Enterprise. All other things, I would say HTTP Boundary is probably the easiest option, right? Okay, so now moving on to SSH session recording, which is now GA as part of the .13 GA release. So why did we develop this? Well, Boundary today has various ways to track what users are doing, right? There's audit logs to track what users are doing when they log on to Boundary components like the workers or the controllers, but that's not enough. Many organizations need more than that. They want to see what's happening with their end users, what are they doing when they log into that infrastructure, what commands are they running, right? And the reasons they want that is, it's fairly obvious, but they have certain compliance reasons, regulations that they need to abide by, or hopefully this doesn't happen to everyone, but in the event of some type of malicious act, they can figure out what happened. They can investigate. They can look into it and then figure out a remediation plan from it, right? So with that, that's the reason why we came out with SSH session recording. So again, part of the Boundary.13 release, administrators now can record and, more importantly, play back these sessions as needed, right? These recordings are stored as files onto S3 buckets, AWS S3 buckets. So one of the requirements is that the customer or the user does have to provide a storage. In this case, today, we're only supporting AWS S3, but more storage is to come. But in any case, they supply the storage, so they completely own all the files themselves, and none of it touches HashiCorp, right? So once it's in their S3 bucket, the files are also signed to ensure that they're tamper-proof, right? And so this is supported on HTTP Boundary and Boundary Enterprise as well. By the way, it's only for SSH today, but we will support additional protocols down the road. So I'm sure some of you guys are already thinking that. So in the end, what does this get you? Well, this gets you a few things. We've already touched on some of it, but basically it helps deter or potentially prevent users from doing anything that's malicious or even questionable, right? They know that they're being recorded, so they're likely not going to do any of that type of stuff, right? You can also use this to actively monitor someone who you think is already, acting suspicious, but they haven't done anything, damaging yet, right? So you can kind of monitor that and then cut them off before something really major happens with that user, right? And then the other thing, the other side of it is, if in the event of something happening, they can react to this, right? They can figure out what happened. They can expedite the analysis of the breach of the attack, figure out, who did this, what was the scope of this breach, what were all the systems that were affected, how deep was that, what exact commands do they run, right? And then you can formulate a remediation plan that you can move forward with, right? If a bunch of files were deleted, you can restore from backup. So how does it work? Well, it's pretty simple. So you have the three main components again: boundary controller, boundary client, and the boundary worker. Since all the data goes through the boundary worker on the data plane, that's a natural place where we actually have a recorder. In the .13 release, all workers have a recorder added to it. And that recorder will be connected, will be pointed to an AWS S3 bucket. From an admin point of view, what they would do is they'd go into the admin UI, they see a list of all the sessions that have been created. They get information about the timestamp, the user, the target that they're connected to, and the duration of that session. They can go further in and actually press play and watch all the recordings play right in front of their eyes, right? Just as if someone put a camera onto someone's monitor. There's additional metadata involved with how much data was uploaded or downloaded, and all the associated users and sessions and buckets that are connected with this particular sessions, right? Okay, so let's go into a quick demo here. I'm gonna start with, before I get into that, let me give you a quick rundown of what I'm gonna demo. Very similar as some of the diagrams before. I have a controller, I have a worker, and I have a boundary client. I'm gonna try to connect to an Ubuntu host. The worker has something called a tag on a worker, and I labeled it dev. That's how we connect the buckets to the workers themselves, but by using tags, right? So keep that in mind. I'll show you that in a bit when we go into the video itself. But basically, we'll connect it to an S3 bucket. We'll then go into show you a quick, quick view of how you can inject credentials and configure that, right? We've talked about it earlier, so we'll show you what that looks like as well. And then we'll actually go through, I'll change hats, go on as a user, log in, run some commands, and then we'll play it back, right? Right, so here we go. First, I'm just gonna simply log in, and in this scenario, I'm the admin right now, right? Uh-oh, let's try that again. Okay, play through here. Okay, I can't touch the button because it's gonna advance and kill the video. Okay, so I'm logging on as an admin in this case, right? So here's the admin UI, I go in. Currently, there's nothing configured. So there's no session recordings configured. There's no storage bucket configured. So we'll go in and create that now, right? So it's pretty straightforward. You give it the name of choice. I'm going to call it global storage bucket. All right, give a description if you want. Then here's where you enter the AWS S3 information. So the bucket name, the region for that bucket. In this case, is US East 1. And the access key and the secret access key 2, so that boundary can have permissions to write to that bucket, right? And then here's a tag, right? So I have dev as the tag, so it'll go out and search for any worker that has the tag dev. So if I have 10 workers and 5 of them have the term dev, then I'll use those 5 to connect to the S3 bucket. The other 5 will not, right? Okay, so we'll go into the orgs here. Can we pause it real quick? Okay, so if you, again, maybe you guys know this already, but I'm just going to do a quick explainer for some folks who are new to this. There's the concept of organizations, and then there's projects. An organization is just a way for you to organize your resources. So in my case earlier, there were like 4 or 5 organizations that are divided up into Azure, AWS, GCP, and on-prem, like some on-prem data center. So I went into the on-prem data center. Then you have projects, which is another way for you to further subcategorize or further organize your resources, right? So if it's a physical data center that is the org, in that physical data center, maybe I have different rooms that I would organize this in, or different racks, or different type of targets, right, or different type of components. So that's basically what it is. Okay, can we continue? Okay, great. So I'm going to click on one of my projects here. And in my project, that's where all my different targets are, all my different things I want to connect to. In this case, I have one target. This target is pointing to my Ubuntu host that I showed you in that diagram, right? So it's going to point to the Ubuntu host. Here's where you can also add the credential injection as well. I'll go ahead and enable session recording for this specific target. When I enable it, I can choose from the different buckets that are available. I only have one, so I'll go ahead and select that. I'll say save. And now let's go ahead and add credentials in here so it can inject it on behalf of the user. So right now there's nothing there. First thing I'll do is go to the credential store to create the credential itself, right? So in the credential store, you can choose internally, the built-in one, or Vault. For simplicity, we'll use the static one. And then we'll actually, that's the store, right? We'll create now the credential itself. For this Linux host, we'll use username and key pair. Username is going to be Ubuntu. And we'll add the SSH key right there, and we'll save it. So the credential's now inside of Boundary. We can now go add that credential in the on the target itself. So it points towards that credential for any time a user wants to connect to that target, right? So now I'm going to switch hats. Going back, I'm a user. I'm using a desktop UI. Actually, I'm using a desktop and a CLI. So I'm going to show you a little bit of both. So the desktop shows me I have 3 targets me as this user, am allowed to connect to, right? I can also filter things out as well by projects. But basically, I can click on connect, and I will be able to then use my terminal to get in. Or I can get the ID of this target, and I can use the CLI. So I'm showing you a little bit of both. So on the CLI, I'll log in, authenticate with Boundary, right? Just like I logged in with the desktop CLI or UI. With the CLI, once I authenticate, I type in the Boundary command with the ID of that target using the Boundary's built-in SSH client, and it takes me right in, right? No passwords were asked of me. It just took me in. And then now we're just going to run a few commands, and then we'll play that back, right? So we'll do a sudo update, and then you'll see this all play out here. Once we're done with that, I'm going to go back and put on my admin hat. Let's go into the session recording itself. A new session just popped up, right? So we will then go into that session itself. You can see the timestamp, you can see the duration, you can see the information for that session that bytes up, bytes down, and then if we go into play, you can see the exact commands as if, again, a camera was put right on there and showing everything I did in detail, right? And you'll see me doing the ls and then the update itself. All right, so at this point, obviously we're not going to play this whole thing out, but you get the point at this point, how quickly it is you can turn around and just watch a session that was just recorded. All right, and the last thing I want to mention is you have all the files right here as well. Go in your S3 bucket itself to see all different files. They're signed, tamper-proof, so you have full ownership of those files. All right. So yeah, that is basically the demo. I highly encourage you to go on and try out HTTP Boundary, or if you want to try Enterprise, you can request a temp or trial license from us. So really appreciate your time. Thank you very much. I'll be happy to answer questions after this and have a longer conversation if you want. All right. So thank you.